My name is Murli Madan Gopal. I'm a software solutions architect at Intel. I work closely with IBM to enable that their software is optimized to run on Intel technologies, and Intel IBM Cloud has the best Intel technologies available for users to consume. And together with me, I have Alex. He's the real worker. He's a software solutions engineer who develops solutions, Intel software solutions, and get it deployed on IBM Cloud. So uh, the AI landscape, even though is broad, and currently the focus on generative AI and um, large language models. If you see here, the enterprise market still is consuming a big portion on traditional machine learning, deep learning, and analytics. And this is where Intel shines. All our technologies, be it the CPU, GPU, NPU, or accelerators, are all optimized to run the classical machine learning and deep learning workloads, and they do also do great on generative AI workloads. So as you see here, even by 2027, the enterprise market would still have a lot of machine learning and analytics. The generative AI part is growing, but we have to look at AI holistically, particularly when it comes to enterprise. So, what are the key customer challenges when it comes to AI? As you see here, currently AI is associated with one vendor, and uh, and primarily the solutions available are all expensive because of that. So, um, what the market needs is multiple vendors who can provide GPU or AI solutions at affordable cost. The second thing is um, the technologies that are being used right now have proprietary stuff like CUDA, software solutions, and and closed technologies and networking, which makes it difficult for customers to move to other vendors or other technologies easily. Their software stack needs a lot of changes to make it happen. And the third thing is, what is important is you want customers want solutions that can scale from one node to multi-node and come back to smaller size and be have their software scale efficiently across the nodes and be available when they want it and not use it when they don't. So this is where the maximizing efficiency comes into the picture, where enterprises are challenged with the costs of AI and particularly generative AI. They want to have ultimately generate the ROI in their businesses and provide value to their customers. So these are all the concerns and challenges um, customers look to as a try to adopt generative AI um, into their solutions. So where does Intel fit into the picture? So the key thing here is, as you know, Intel has a big market spanning from laptops, desktops, and the edge and the data center, and the public cloud, right? So the key advantage Intel has is we have our x86 architecture across the board, and one of the big things is we have been doing this for a while, and we have solutions which run from the PC to all the way to the cloud. So we can bring that connectivity so a developer or a customer can run their same software anywhere and have the seamless experience. And how do we do that? As you know that we're a leader in the AI PC category. Nowadays, you could run some of the big models even on your laptop. And this particularly AI PC is where the market is moving towards. And you should be able to get a laptop like this for $1,500 right now in the market. And all our OEMs carry this. So this has the CPU, GPU, and the NPU. All of this helps run generative AI models locally, right, on your laptop or desktop. And when you go to the edge, we have already have solutions available for different vertical industries, which we can which are available as ready to market solutions. And we have leveraged our edge solutions to also deploy AI at the edge. And finally, when it comes to the data center, we have both. I'll be covering our Gaudi accelerator. So we have both accelerators and CPU based technologies, which can help you quickly get started on the data center to run um, AI, generative AI workloads in your data center and both in the cloud. And we do have a lot of, this is the one Alex would be covering. We have already many use cases available and ready to go, both on IBM Cloud and in general in open source, which you can take and just run it across all of our technologies. So this is again a continuation of our Intel AI strategy. As I said, the key here is being able to run anywhere, and we support an open ecosystem of software, and so that makes it easy for users to take it, adopt it, and change it as they want it to customize. Some of the technologies there are OpenVINO and OPEA, which Alex would cover, and we have this thing called day zero model. So Intel supports all the models that are coming in. As you know, that in generative AI space, we have a lot of models coming in. And recently the Quan models came and the Llama 4 from Meta. We supported it at day zero of launch. So what that means is we take the models, work with the ISVs to optimize it, and when they launch, you would be able to run it across all our technologies from laptop to the cloud. So that's the day zero promise Intel has. And we try to do that in a cost effective way and also with a low cost and a low energy footprint. So this is where Intel is trying to democratize AI and have put in the right technologies and solutions to make it happen. So what is the connector? What are we doing along with IBM? I mean, for me, the day-to-day job is working closely with IBM. And as you see here, IBM has a long-standing history on software and uh, particularly on the enterprise. The recent acquisition with Red Hat has made the hybrid cloud all the more important. And this is where I think AI is headed, particularly for the enterprises. Hybrid cloud is going to be a big part of it. And this is where we, Intel, kind of works closely with IBM, and as I said, making sure that software is optimized for Intel and all our technologies are available in IBM Cloud, and ready to consume. The other part is security is a big part of computing right now. So we have this confidential computing initiative with TDX and XGX technologies that are available on IBM Cloud, and our latest Xeon processors with AMX. AMX is a technology which allows you to run generative AI models on the CPU easily, and we'll do that with on IBM Cloud with deployable architectures. But you can use your CPU to prototype, and then we have Gaudi 3, which is a GPU or an ASIC accelerator, which can run your large language models at scale. So with our collaboration with IBM, we make IBM Cloud as a first choice for running our Intel AI accelerators and technologies in public cloud. So this brings us to Gaudi. As you know, Gaudi is our solution to NVIDIA accelerators like H100 and H200. So this is a customized ASIC. What makes it great about Gaudi is it is not a general purpose GPU. It's designed specifically for AI. So AI traditionally does needs three things: compute, memory bandwidth, and efficient networking. Right. So we have addressed all three of this. We have specialized matrix math or MMU, you call it matrix multiplication units, and a lot of tensor processor cores, which give the compute capability. And the Gaudi system comes with 8 of these cards, so which are connected with efficient networking. The big thing we're focused on is industry standard networking, which makes it easy to use and less costly in a way. And third is memory bandwidth, right? Memory bandwidth is very critical for AI workloads because all the computations that happen in the matrix multiplication, when they need to be transferred, is it's through the memory bandwidth. So we've added HBM capacity um, uh, and memory to make this happen. And what does that bring, right? As I said, the day zero challenge, we have almost all the industry models like large language models running, and we have done some benchmarking with a third party company, Signal 65, who compared the Gaudi 3 accelerator on IBM Cloud with NVIDIA H100 and H200. And what you see here is really the open source models shine in terms of performance. This is particularly on the inference performance on cost of inferencing 1,000 tokens per second, but great inference performance. And if you see here, IBM shines through their own Granite models, which they have open source, and we do even better on the Granite models, right? And so that way, it is a cost-effective AI inferencing with this other competitors available in the market. And best part is it runs on open source software. I'll cover this in the next slide, but we support, and IBM is a big proponent of open source technology. So PyTorch, we have collaborated closely with IBM to make sure that all of this PyTorch is optimized, all frameworks and libraries run and run in a safe environment, right? Like confidential computing, confidential AI is a big part of our strategy, and so is IBM. So we make sure it runs in a secure way and is available easily to consume on IBM Cloud. The last part is the scalable part, where you can scale from one node to 32 or 64 nodes as models become bigger to make sure that the performance is also scalable and and near linear, right? And that's what users expect of us: scale up and scale down. So there is a QR code on the right side. You guys can click and go read that benchmark and look at these results. So this is the Gaudi software stack. As you see here, um, we support almost a lot of use cases. These use cases on the top, the enterprise RAG use cases, are all open source. And you could take that and we'll make it even easier. These will be available in one click on IBM Cloud, but we have a lot of ready to available use cases for different verticals of choice, and you could just take that and run it. And from the model standpoint, we support almost all major models and the day zero promise, where we work and optimize it when it's launched. We support, as I said, our big focus on open source frameworks and libraries. We support pretty much all the frameworks and libraries listed here, and the inference engines like VLLM, Ray, TGI, all of that are supported and optimized. And to add that, the key part here is the Red Hat. We've supported on top of Red Hat OpenShift AI, and we already have solutions available with Red Hat on IBM Cloud, which runs on the Gaudi accelerator. To sum up, how do you consume Gaudi 3 accelerator on IBM Cloud? Right now, it is launched and available as a VPC solution on IBM Cloud. They said then you could also consume it as Red Hat OpenShift at the OpenShift layer and provision it on IBM Cloud on Gaudi. We're working with IBM watsonx. watsonx is the IBM premium software for generative AI, which covers both data, AI, and governance. So we're working with enable IBM watsonx software to run on our Gaudi 3 accelerator. And this could be used both on-prem and as a service on IBM Cloud, or you can deploy it on your own on IBM Cloud. So it will be available on both SaaS, PaaS, and an on-prem model. And this should be available by end of Q2 or early mid Q3. And then if you're a traditional Kubernetes service, we are enabling the Kubernetes IKS to also be available. So you can spin up a IKS cluster on IBM Cloud and use it. And last, how do we bring all of this together? So we have all these offerings which are software, but how do we bring it together? That's through the deployable architectures on IBM Cloud. So with one click on the IBM catalog, we're going to bring all our use cases, solutions, OS images, which will be available ready to consume on the IBM catalog. So all the user has to do is a couple of clicks, and they should be able to deploy this and get running immediately. So this is to summarize, we have solutions which are open, secure, and competitive in terms of performance and ready to be available on our IBM Cloud for users to consume. Now, I'll give the floor to Alex, and he's going to show you all the good technologies I talked about and even do a demo to show how it works. Back to you, Alex.
All right, thank you, Murali. Hello, everyone. My name is Alex. I'm an AI software solutions engineer. I do primarily technical consulting for customers who want to build GenAI apps on our data center products, including Xeon and Gaudi. One of the tools and solutions that I'll present to you today is called Intel AI for Enterprise Inference. So I'll talk about the motivation behind creating this solution and how you can deploy this on IBM Cloud, which is powered by our Gaudi 3 AI accelerators. First, the problem I want to present is that in terms of the AI revolution that's been happening, traditionally we've been focusing on training these large language models, but in the past couple years, it's actually inference that's going to be growing much faster. And that is because inference is what's really going to help enterprises get realized value, get that return on investment to solve specific industry problems that they are most interested in. And the problem with this is we need to be prepared to have the right infrastructure to support the growth of AI inference. When it comes to infrastructure, you need to ensure that you have enough compute power, has to be scalable, needs to be secure, and also has to be compatible with heterogeneous hardware architectures, whether it's CPU, GPU, or AI accelerators. At the same time, you also have to consider the cost of maintaining and purchasing and operating all of this infrastructure. What Intel has done is to enable low cost or cost effective inferencing with industry standard APIs on our Gaudi AI accelerators through IBM Cloud. So we have partnered with IBM to bring to you this solution called Intel AI for Enterprise Inference. What it is it's an inference stack that will automatically deploy everything from the ground up, setting up your drivers for the hardware to the middle layer to deploying the actual large language models that you want to work with. Once these models are deployed, you can access them through industry standard APIs, such as OpenAI compatible APIs, to make it, and we chose to use this to make it easier for you to use it, because we understand a lot of customers are already using such an API through OpenAI. The benefit of Intel AI for Enterprise Inference is that it will allow you to have cost-efficient inference while meeting any of your performance requirements, throughput, latency. It supports all of the open source models that you may already be working with, Llama, DeepSeek, Mistral, just to name a few. It's also seamless to use because instead of having to reset up and ramp up on a new hardware platform, bring up all the source code, you can actually reuse the code you currently have and just make a few changes to your code where you point to the specific endpoint URL of your system, as well as pass in a key to access these models through an OpenAI compatible API. This diagram here shows you what exactly is set up when you deploy Intel AI for Enterprise Inference. At the very bottom, we have the hardware platforms, Xeon CPUs and Gaudi AI accelerators. We install the drivers, the OS. We use Kubernetes as the orchestration. We also put in security, including API 6 and Keycloak. We use a model inference serving engine called VLLM, so that when you deploy these models, it will give you increased throughput and lower latency without you having to do that yourself. For observability, we support Grafana dashboards and Prometheus to collect metrics for you to take a look at, see how your GenAI application is doing while it's running. For the model endpoints, so you can choose which of the models you want to deploy. You can actually deploy more than one at the same time, so that once they are deployed, all you have to do is really access this entire black box through an OpenAI API with your base URL and an API key to access these models. And the best part is this solution is also open sourced. This slide here I already covered, mentioning about why we decide to make this OpenAI API compatible. It is so that it makes it seamless for you to try using all of the entire inference stack that we have set up for you, including using Xeon CPUs and Gaudi AI accelerators to do your GenAI inference. Another interesting feature is called LLM dynamic routing. So how this works is, say you put in a query, and depending on the complexity of the query, it will automatically route to the most appropriate hardware to process that query and give you a response. If you're asking a very simple question, then it will route it to an Intel Xeon CPU to do the inference. For that query, it probably doesn't need to use a 70 billion parameter model. It can probably handle it in a 7 billion or 8 billion parameter model. And additionally, you running a Xeon to do this inference will cost much less than running the same thing on a GPU or an AI accelerator. Likewise, if you were to ask a query to do something much more complex, say solve a particular matrix problem, then it will route the query to the Gaudi AI accelerator and use a much larger model. And so by automatically doing this for you, it will help you achieve much better cost efficiency. This diagram sums up what Intel AI inference can do for you and how it looks on a higher level. So on the right-hand side, you can see on the Kubernetes cluster, you can set up any of those large language models that you are interested in working on. And in the middle is the OpenAI API, where it's nothing but the HTTPS endpoint for your server. And you also pass in a key so that you can access each of those large language models deployed there. Now, the beauty of this is that you can just deploy Intel AI for Enterprise Inference with all of these large language models on, say, a single server. Then use this to power all of the applications that you have, whether it's on the cloud or mobile or enterprise. You no longer have to deploy these models locally on every single hardware device that's running your applications. I like to think of this as, leveraging the power of all those large language models that you wouldn't have been able to deploy in your applications or on the edge. Hence, by setting up this infrastructure for you in a automated fashion, you don't have to worry about infrastructure setup. Now you can focus more on the actual solution development, which is probably or most likely more important to you. I promised you there are very little code changes needed. Your code might look something like this. You're probably already using an OpenAI API to access your models. For Intel AI for Enterprise Inference, it's the same thing. All you have to do is specify your base URL and pass in your API key to access the models you need to do inference. Now, this Intel AI for Enterprise Inference is part of a project called OPEA, Open Platform for Enterprise AI. It is a Linux Foundation project with over 50 partners. Intel is one of those partners to streamline the development of GenAI applications and workflows. Due to time, I won't jump into too much detail, but essentially how it works is there's a concept of using these microservices. Each of these microservices perform a specific function, like embedding or doing LLM generation. You can put these microservices, or I like to call building blocks, together to construct an entire pipeline. A megaservice consists of at least one of these microservices to perform a particular task or application. And finally, the gateway is how your users will interact with these different microservices. These are the different Gen AI examples that actually put several of these microservices together to address a particular use case, including agent Q&A, chat Q&A with RAG, audio Q&A, multimodal Q&A, etc. Now, how does OPEA tie with Intel AI for Enterprise Inference? So what we're doing here, let's say we have a RAG pipeline here. This is actually the chat Q&A Gen AI example from OPEA. What we are changing here is the highlighted orange box is the LLM generation is no longer going to be performed on the hardware platform that has this solution deployed. It's going to access the remote server that you have the large language model deployed, whether it's Llama or DeepSeek. And so we're using that infrastructure to power this application. Now, Murali mentioned this earlier. We want to make it easier for you to get access to this hardware, and the best place to do that is IBM Cloud, which is the first cloud service provider to provide Gaudi 3. Currently, it supports virtual servers on VPC, Red Hat OpenShift, watsonx is coming up, and same with Kubernetes. We also want to highlight the concept of deployable architectures. So you can think of this as a set of cloud automation where you you set up do a couple clicks to set up, and it will use Terraform to automatically deploy your entire Gaudi 3 server on IBM Cloud with those open source models that you are interested in. And so we support deployable architectures for Intel AI for Enterprise Inference, as well as one of the OPEA GenAI examples, a productivity suite, which consists of different use cases. All right, I don't have a lot of time, but I wanted to quickly show you this demo of the productivity suite powered with Intel AI for Enterprise Inference. So let's say here I have all the different models that I have deployed with Intel AI for Enterprise Inference. So for the example, I'm just going to pick Llama 3.1, 70 billion, and here we can just ask it a really simple query. What is generative AI? And so what's happening here is I'm using an OpenAI API to use this model that's deployed on IBM Cloud. And you can see that, so for this application or whatever application you're building, you're essentially harnessing the power of those LLMs without having to deploy it on your solution itself. This productivity suite can also do other things, including summarize content. So let's say I have a document here that tells me what is OPEA. What I can do is I can also upload the file, and it will give me a summary of that document. Yeah, so this is the productivity suite GenAI example powered by OPEA. All right, so let me go back to my slides. So that concludes our webinar today. Just wanted to give you several resources if you found this interesting. The first QR code on the left is a customer interest form. It will connect you to someone from our team so that you can get access to Gaudi 3 on IBM Cloud. The middle QR code is a white paper from Signal 65 doing a very thorough performance analysis between Gaudi 3 and the GPU competition, including H100 and H200. So check out that paper if you are interested in evaluating whether Gaudi 3 could be a right fit for you. And finally, on the third QR code on the right is the GitHub to Intel AI for Enterprise Inference. That is part of the OPEA project, where you can actually deploy this onto an on-prem server. But if you are working with IBM deployable architectures, which will be available very soon in the next coming weeks, you won't have to worry about that source code per se. It will automatically deploy the server for you. All right, with that, thank you so much for attending our session today. I hope you found this session useful, and Intel AI for Enterprise Inference can help simplify and reduce your infrastructure costs.